Welcome, dear students. Today, we'll be learning about operations on events. Let's start? Let's start. If you can see here, a regular dice is rolled once randomly, and the upper face is observed as. What is the sample space? So the question here is asking us, what are the different options that I can have as an outcome? If we threw the dice, what is the possible outcomes? Yes, thank you. It can be 1, 2, 3, 4, 5, or 6. Anything else? Definitely no. So, the sample space is the possible outcomes. As you can see here, the possible outcomes are 1, 2, 3, 4, 5, or 6. Okay, the event of having 7. Is it possible to have 7? I don't think so, right? So, the event of having 7 is an empty set. It's phi. It's not an option. So, if the event is not an option, and this event can never happen, it's called what? It's called an, excellent, good job. It's called an impossible event. So, for the impossible event, what is the probability of that impossible event? The probability is all what I want over all what I have, right? So, in this case, it's not possible to have any of the above faces as 7, so the probability of this is 0. Let's move on. The event of getting a number less than 9. What are my outcomes again? Again, they're 1 through 6. So all of them are less than 9. So they're all less than 9. So this event is called a certain event. And the probability of this event is the total, which is 6 out of 6, which is 1. The event of getting a prime number is, so tell me now, prime numbers, what are the prime numbers? Take care. Yes, good job. That 1 is not a prime number. 2 is the smallest prime number. So it's 2, 3, and 5. And it's a subset of the sample space. And the probability of it is 3 numbers out of 6, which is half. If A is an event of S, where A is subset of S, then the probability of A is the number of elements in A over the number of elements in S, where N is the number of elements in A and NS is the number of elements in the sample space S. Probability of A, or actually a P of A, is the probability of A as an occurring event. If it's 0, so this is called an impossible event. If it's 25%, it's called a less likely event. If it's 50%, it's called an equally likely event. 75% is called more likely, and 100% is called the certain event. Let's now move on to the intersection between two events. If A and B are two events from a sample space, then A intersect B means that event A and event B occur together. If you can check this Venn diagram, if this is A and this is B, so the common part between them is called the A intersect B. Let's move on to one of the examples to check our understanding. A set of identical cards numbered from 1 to 8 with no repetition, mixed up and well. If a card is drawn randomly, write down the sample space. So the options that we have here are numbers from 1 to 8. So the sample space is 1, 2, 3, 4, 5, 6, 7, and 8. Write down the following events. The first event, the drawn card has an even number. So A are even numbers. What are the even numbers in here? 2, 4, 6, and 8. Next, event B, the drawn card has a prime number. Yes, very good that you guys remember that 1 is not a prime number, so it's 2, 3, 5, and 7. Event C, the drawn card has a number divisible by 4. So they're only 4 and 8. Remember, event A, even numbers. Event B, prime numbers. Event C, numbers divisible by 4. So here, use the Venn diagram to calculate the probability of A and B occurring together. So if you can check here, here's A and here's B. So where's the intersection between them? Yes, it's this. So it's only one number over how many numbers do we have? 8 numbers. A and C happening together. So here's A, here's C. Where's the common part between them? Where's the intersection part between them? It is C, which is 2 elements out of 8 elements, which is 1 over 4. B and C together, as you can see that we don't have any intersection between B and C. That's why the probability of B and C together is 0, because we have no intersection between A and B. 0 over 8 is 0. Mutually exclusive events. It is said that A and B are mutually exclusive events if A intersect B is phi. Phi means there is no intersection between A and B. And it's said that a set of elements are mutually exclusive if every pair is mutually exclusive. So mutually exclusive means what? Means that there is nothing in common between them. There is no intersection between them. As you can see here, here is A and here is B, and there is no intersection between them. So A intersect B is phi, where the probability of A intersect B is 0 over the total, which is also 0. Let's move on to another example, which is example 2. A regular dice is rolled once. Write down the sample space. The sample space are the possible outcomes for me. As you know, the possible outcomes are 1, 2, 3, 4, 5, and 6. Question 2 is asking us to write down the following events. A is the event of getting an even number. So A, what are the even numbers? Excellent. It's 2, 4, and 6. B is the event of getting an odd number. So B is 1, 3, 5. Where C is the event of getting a prime even number. A prime even number, as you all know that 2 is the only even prime number. Continuing on this, find the probabilities of the occurrence of the two events A and B together. A, 246, B, 135. So, as you can see that they will not occur together because the even numbers and odd numbers. So here, in this case, the probability of A intersect B is 0. In question B, the occurrence of two events A and C together. So in A and C means the probability of A intersect C, which as you can see here, it is, yes, number 2, which is 1 out of 6. The second part, after talking about the intersection, we'll be talking about the union. If A and B are two events from the same sample space, then the union of the two events, which is denoted by the symbol A union B, means the occurrence of two events A or B or both. Occurrence of at least one event. If you check this Venn diagram, here's A and here's B. So if I take them both together, this is the A union B. Let's check example 3. Nine identical cards numbered from 1 to 9. A card was drawn randomly. Write down the sample space. For the sample space, we call it S. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Write down the following events. A is getting a card of even numbers. So A is 2, 4, 6, and 8. B getting a card with an even number divisible by 3. So an even number divisible by 3, it's only 6. C, a card with a number greater than 5. So C greater than 5 are the numbers 6, 7, 8, and 9. Following example 3, use the Venn diagram. Here's the Venn diagram where A, B, and C are there. The occurrence of A or B, as you can see here, A or B means A, the probability of A union B. So it is A and B together. If you can check it, it's 1, 2, 3, 4, 5, 6. Or actually, it's the probability of A plus the probability of B minus the intersection between A and B. So the probability of A is 4 out of 9. The probability of B is 3 out of 9, where the intersection between them is 1 out of 9. So as you can see here, this will be 6 out of 9, which is 2 over 3. Or you can do it A and B, if you count them, 1, 2, 3, 4, 5, 6, it's 6 out of 9, which is 2 over 3. The occurrence of A or C, as you can see here, the probability of A union C. If you count them, A 1, 2, 3, 4, where C is 5. So in this case, they are 5 out of 9. Find the probability of A plus B minus probability of A intersect B. This is what we got at the top here. So probability of A is 4 over 9 plus probability of B is 3 over 9 minus the probability of the intersection between them. It's 1 over 9, which is 2 over 3. So in question A, you can just go and count, as I said, A and B together, 2, 4, 6, 8, 4 items, plus another 2 items in B. So there are 6 items out of 9 items, so it's 2 over 3. What did we notice about A union B? A union B is the same as the occurrence of A or B together. So we have some important rules that we need to take care of, that probability of A union B is the probability of A plus the probability of B minus the intersection. Probability of A intersect B is the probability of A plus the probability of B minus the union. So don't forget that probability of A union B is the probability of A plus the probability of B minus the probability of A intersect B, where the probability of A intersect B is the probability of A plus the probability of B minus the probability of A intersect B. Here in example 4, the question says if A and B are 2 events in the sample space of a random experiment, complete. How can we find probability of A union B? You know that very well, that the probability of A union B is equal to the probability of A plus the probability of B minus the probability of the intersection between A and B. So this is equal to half plus 2/3 minus 1/3, which is equal to 5 over 6. Question number 2. If probability of A equals half and the probability of B equals 1/3, then the question is asking us to find the probability of A union B in the following cases. The first case, that I have the intersection given. So in this case, the probability of A union B equals probability of A plus probability of B minus the probability of the intersection. So it's half plus 1/3 minus 1 over 8. If you do your calculations, it will be 17 over 24. And what if A and B are mutually exclusive events? Then yes, excellent. The intersection is 0. The probability of the intersection or the probability of A intersect B is 0. Then probability of A union B is probability of A plus the probability of B. So in this case, it's 1 over 2 plus 1 over 3, which is 5 over 6. Let's go to the second part of this exercise. If A and B are 2 mutually exclusive events, then the probability of A intersect B equals, yes, you say it? Yes, perfect. It's equal to 0. If A is subset of B, then the probability of A union B is, yes, is the probability of B. Good job. If a regular coin is tossed once, then the probability of getting a head or a tail is, yes, probability of head union the probability of tail is 100%. Good job. If a die is rolled once, then the probability of getting an odd number and an even number together is, this is impossibly going to happen. So it is equal to 0. By now, dear students, we came to the end of our session today. Thank you very much. Study hard and good luck.